Hi guys, this is Thomas Otten, and today I'm going to make a little video about the different heat exchangers on the Porsche 914. Not the most glamorous of topics, but something worth knowing about when you're modifying these cars. Over the course of the production of the Porsche 914, there were several different exhaust systems employed. What this video will go over is the different heat exchangers that were part of these exhaust systems. The heat exchanger variations are as follows. There is the 1.7 liter, the 2.0 liter, the 1.8 liter, and lastly the 75 through 76 version. First, I am going to talk about the difference between the 1.7 liter and the 2.0 liter version. When you place them side by side, you can see that the 1.7 liter version can be most readily identified by the upturn of the pipes before they enter the muffler, whereas the 2.0 liter pipes are more straight. The 1.7 liter version also has the smaller diameter tubes. The 1.7 liter tubes are about 35.5 millimeter in diameter, outside diameter, compared to the 41 millimeter outside diameter of the 2.0 liter. So with the 1.7 liter heat exchangers, and as well with the 1.8 liter, you'll notice that the inlet flange is a welded on flange. For the 2 liter heat exchangers, the flange is not welded on, it is a continuous pipe, but the mounting eyelets are welded on. Next comes the 1.8 liter version. These look very similar to the 1.7 liter version. You see they too have the characteristic upturn before entering the muffler, just like the 1.7 liter. You will often see used heat exchangers described as 1.7 liter / 1.8 liter versions. However, the 1.8 liter versions have a larger diameter tube, and this should be noted when sourcing a replacement for your 1.8 liter exchangers. The tube diameter is about 41.5 millimeter, which makes them very comparable to the 2.0 liter versions. In fact, with the right performance muffler, an exhaust system based on the 1.8 liter heat exchanger will perform very similar to the 2.0 liter system. The last system is of course the 75 through 76 version. The exhaust system of these cars was redesigned to comply with new emission regulations. They can be identified by having the reaction tube collecting into a single piped heat exchanger with single outlet flanges. For some California cars, the system also included a catalytic converter integral with the muffler. These heat exchangers are generally considered power robbing and not highly sought after. By switching out the system for the earlier 2.0 liter system, you would experience an increase in power. All 75 and 76 cars had those heat exchangers, whether you had the 1.8 liter or the 2.0 liter car. So here we have a table that summarizes the different diameters of the various heat exchangers. And so you'll see that if you calculate the area going from the 1.7 liter to the larger diameter exchangers, it's about a 30% increase in cross-sectional area. Also listed is the stainless steel heat exchanger cross-sectional areas, which I will cover next. So that about does it for the stock factory heat exchangers. Now I'd like to take a look at the aftermarket stainless steel heat exchangers that have been available. This is generally considered a nice upgrade. Being stainless steel, they are not prone to rusting out as the original steel heat exchangers do. They are also considerably lighter. The inside diameter of the pipes is about the same as a 2.0 liter or a 1.8 liter heat exchanger. Therefore, these can be a performance upgrade. However, the tube thickness is thinner. Thinner walls mean that the sound is not attenuating as much, and these will make the car somewhat noisier. The thin walls of the tube have been known to crack, and the flanges have been seen to corrode. Overall, they are a nice upgrade because the shell does not rust. When the shell of the heat exchanger rusts, the cabin heat can be considerably reduced. I do want to point out one difference in stainless steel heat exchangers, and that has to do with the sealing surfaces. The way the heat exchangers seal to the exhaust port of the cylinder head is by way of a copper crush gasket. The crush gasket has about 3.15 millimeter of sealing surface around the perimeter. All of the factory heat exchangers have sealing surfaces on the order of 3 millimeter as well. However, when you look at the stainless steel versions, their sealing surface thickness is much smaller, on the order of 1.5 millimeter. So what that means is there's a greater chance for these to leak exhaust gas past the gasket. The stainless steel heat exchangers can be harder to seal when installing because of this reason. I've personally found this to be the case. So that about does it for the 914 heat exchanger roundup. I probably haven't covered everything, but I hope I've covered at least enough to get a reasonable understanding of the differences and things to look out for when you are sourcing heat exchangers for these cars.